Hello everyone, welcome back to this amazing session at PW. I hope you have attended the previous session where we have done the revision of the chapter of surface area and volume. Now in this case we are going to start with a new chapter and the chapter's name is statistic. I have left you saying that the previous chapter was entirely formula oriented. So is there any difference? No, there's not much difference on that note. The only difference which comes into picture is that you are going to learn multiple formulas in this session. In the previous chapter, we had multiple formula which you have already learned in previous grade, but that's not the case over here. In this case, when you are going to talk about three important things, I hope you have already heard about them. That is mean, median and mode. Now these are the terms which you have already heard about, but the formulas which you are going to learn will be very new to you because whatever we have learned before, that was for different kind of a data. Over here in this particular grade, we are having a different kind of data. So without wasting any more time, let's start understanding the statistic and their formulas. So for that first case coming up over here, what are we going to learn? We are going to talk about all the central tendencies. So what is the central tendency? I'll explain it, nothing to worry about. The central tendencies we have as mean, median and mode. And finally, to relate all of three, we are having empirical formula. As the name suggests, it will be empirical in nature. So first of all, the first question coming to our mind should be, why are we learning statistic? What exactly is statistic and what's the importance of it? When we talk about statistic, the one basic quote comes to my mind each and every time, and I would like to say it out for you as well, that data is the new oil. We are emphasizing so much on data. What's so special about it? So if I have to give a clue about why statistics is important and why are we learning it. So at the moment you are watching a video on a YouTube, right? So like this, there will be multiple videos coming in your feed. I hope you are familiar with the term feed because nowadays social media is a common place and many of you find a wall where you are having different feed. So something would be appearing over there which you like, and how they are knowing that you like that particular kind of a material or any kind of a particular video, because they have been extracting data out of you. When we say extracting data, so whatever video you are watching, for how long you are watching that, how much engagement you have with that video. So there is a collection of data. There is a collection of data happening. This is the first thing, collection of data happening. Now we are having a collection, so automatically there will be a processing as well. A processing would also happen. Now when we are having a processing, something come out that is called as the evaluation, or we can say we are having an interpretation. If my spelling is wrong, please pardon me for that. I am very weak with the spelling parts as well. So over here, we are going to interpret your behavior over there. How interpret the behavior? What kind of videos would be liking? What kind of a videos should be appearing on the wall? You would be more interested to watch it. So at the moment you're watching a video where a teacher is giving you a lecture on statistics. So like this, there will be more videos coming on your wall which will be showing teacher teaching any particular topic which is related to grade 10. So it might be me, it might be some other teacher, it might be some other subject, but something of that sort, because the YouTube algorithm do understand that you are interested in this matter. So this is how data is working, and that is what exactly statistics is all about. So this is what we learn in the chapter of statistics. So this is the importance of the statistic, and that is why we are learning it. So each and everything over here is related to data, and that is why data is the new oil, because basically we are dealing with the personal stuff of yours. We are understanding your behavior, how you conduct yourself, what's your liking, what you don't like, what you are interested in, where you're spending your time, where you're not. So enough of the talking about the dilemma. We are having the social dilemma kind of a thing. Moving ahead, and let's talk about how this data basically start with. So let's talk about the basic thing first of all. So what's the basic thing, sir? So over here we need to understand, when we talk about the data as per se, we have few parameters which make us understand something about data. For example, if Virat Kohli is playing today, so Virat Kohli has played in multiple matches and we are having the scores of Virat Kohli in multiple matches. So let's say he has scored different runs. In one match he scored 25, another match he scored 37, another match he scored 59. Then he scored again 21, then he appeared in the match where he scored 123, and then he reduced back to a score of single digit, which is 9. Now, over here we have a different set. We are having a different scores in each and every match. How many? 1, 2, 3, 4, 5, 6. In total 6 matches. Fine, sir. Now, in this case, you have to make a understanding how good a player is, how good Virat Kohli is. Obviously, you know how good he is, so there's no point talking about that. But let's say a random player would have been there. So if a random player is there, so you have to get important information from this data. Otherwise, this information is nothing more than a numbers. So what's important about it? Now, from this particular numbers, you have to extract anything important, and that is basically a representation of number. So, if I have to understand how good a player he is, whoever has scored these many runs, so I have to come up with the average in each and every match, how much I can assume that he would be scoring, somewhat something. Let's say most of the time he has scored somewhere around 30s. So 25, 21, 57, 59, 37, somewhere he's scoring around 20 for sure. 20 for sure. He'll not go below 20. Now in one match he has scored 9 also, but that is compensated. In one match he has scored 120 as well. So right, so you're understanding, we are finding out the average, which is basically giving me an indication, the representation of this data. So a single digit which can appear as a representation of this entire data. That is what we are looking forward to, and we call these things as the central tendency. This is what we are looking in data, so that we can make the understanding from that particular data. We can have a clue what is this data representing. So to have the central tendency, another example which you can think of central tendency in a manner is like, let's say a football player is there, Ronaldo, many of your favorite player. Now he is scoring in one match 5 goals, another match he is scoring 1, in one match he is scoring 3 and then 4 and so on. So from that you have to understand per match how much he is scoring. So obviously again you will take a use of central tendency, that will be the summary of the entire data. So the first thing which help us to understand this is mean. What means, sir? So when I told you can take out the average of all these scores, and that will be a representative of this data. So that means that single score coming up will be representative, that okay, in each and every match he is scoring somewhere around this much, somewhere around this much. So that is basically average. Arithmetic mean, what we are talking about over here. So you have calculated arithmetic mean, add up all the numbers, divide by the numbers we are having. How many? 6 innings over here. So divide by 6, that will be the mean over here. So one thing is mean, and the rest of the two we have already talked about in the content, and we have also learned in the previous grade. One being the median, that means lying exactly in between, and the third one is the mode. So if you are familiar with these three words, that's fine, but you should be also having a clear clue that they are representing a central tendency. So central tendency can be understood by any of the three. They are the mechanism through which we have a understanding of the data. Now, we have understanding of data by these three, but we have already learned these three, right? I believe many of you who have learned grade 9 well. You have passed not only in terms of the examination, you have passed well in your intellect as well. So you'll have a clue what exactly is mean, median and mode, and how to find them all. So what's new in this session, sir? Now the new part in this session appears when we talk about the type of data you have dealt with. So previously I have dealt with the types of data which I have written over here. This is a raw data, discrete data. Individual scores are given. But each and every time the data is not like that. Sometimes we are having a lot of data. When we say lot of data, so let's say I have conducted a test and over here there are many students. It's not a single classroom where 5 or 10 or 15 or 20 or 30 students are there. Let's say 500 students are there. So the scores are something like this. So what is this? So individually, a student has scored, some student has scored 83, another 71, 97, 31, 28, and very poor as well 9. Some person who is not even interested in attending the classroom. So he has scored very poorly. No clue what exactly are we talking about, why statistics is important at the first place. So this is the data for 500 students. That is why dash 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 over there. Now, this kind of data is very difficult to process for such a big population, for such a big number. So what we do, we make a group of all this. We make a group of all this, and how do we do that? For this, we make up a group. So let's say if I have to understand how the students in the classroom have performed or in the school have performed, so I'll see how many students were there who have scored between 90 to 100. So if there are more students in 90 to 100, the school is doing well. If there are more students who are lying between, let's say, 20 to 30, many of the students who have scored between 20 to 30, it seems the students is doing very poorly. The teachers should improve, the students should also improve. Without the improvement of the teacher, there will be no improvement of student as well. And if there is something in between, so a student is doing average. So what I'm talking about? I'm talking about the group data. And how does it appear? It appears in this form. 0 to 10, how many scored? 10 to 20, 20 to 30, 30 to 40, 40 to 50, and so on, up till 100. If the examination would have been 100, so final say would be 90 to 100. If examination is, let's say, of only 80 marks, so 70 to 80. Now, this is what we call as class interval. These are the class we have made up. These are the class which we have made up. Now, these are the class we have made up between 0 to 10. How many students have scored marks? So let's say 30 students scored marks between this. So these are number of students. And over here, we also call it as frequency. It is frequency. So 30 times the number appeared between 0 to 10. There were 30 students who have scored marks between 0 to 10. And like this, there will be many more. So 32 scored somewhere over here, 20 to 30, 41 scored, 30 to 40, 51 scored, 40 to 50, let's say 64 scored. So over a period of time, we are seeing the improvement. Many students are lying between, somewhere in between, not at the bottom. And same would happen at the highest point. Many would be lying between the average, right? So the number of students over here represented are the frequency. So how many times we have the scores between 0 to 10, how many we have the scores between 10 to 20 and so on. So this is called as class interval, this is called as the frequency. Now one more thing over here, 0 to 20, 0 to 20. In this case 0 is not 20, 10. 0 is my lower limit. This is my lower limit. So I have started from 0. This is my upper limit. If you observe the upper limit is there in the next group as well, 10 to 20. So basically, where should I consider 10? Should I consider in the first class interval, or in the second one? This is an interesting question, sir. In such cases, always the 10 would be considered in this group. So the upper limit is not inclusive. It is not included in the class interval. So 10, if someone has scored 10 marks, so he'll not be counted in the first group. It will be counted in the second group. So same happens for each case. 20, 20, so it will be considered over here. 30, 30 will be considered over here. 40, 40 will be considered over here. So this upper limit is not inclusive. This is inclusive. This was lower limit, upper limit. What do we call as the range or the class width? The better word to use over here is class width. The class width is basically the upper limit minus the lower limit. UL minus LL. So whatever initially want to come up with, upper limit minus the lower limit will be indicating our class width. So how much big our class width is. So 10 marks, for 10 marks we have considered. It might be 5 marks. So I could have started with 0 to 5, 5 to 10. Then 10 to 15, 15 to 20 and so on onwards. But it is our understanding how we make up the group. So that data is given to you most of the times, or in case if you have to form it, you can form in the manner which represents such a manner that the uniform width is there each and every time, and you have understanding that the number of students lying would be covered in this manner. So this was about the representation of basic data, and this is what is different from the previous grade. Previous grade you didn't dealt with the group data. You only dealt with the raw or discrete data. So when the type of data is changed, the method to calculate is also changing. So the first thing we are going to discuss today is about the mean part. So let's understand how it is going to be different. So mean, as I mentioned, is just an average. So if we have a different number of observations, so mean will be what? Total number of observation. Total number of observations. So we were having the scores from each and every inning. For the 6 innings, we were having the score. So we can add up all the innings score and divide by the sum. Total number of observation would not be coming up over here. The sum of all the observations should be coming up. Sum of all observation. In the denominator, we'll be having total number of observation. What does it mean, sir? The formula doesn't make much sense over here. to make it more senseful, it simply means, let's say in each and every inning how much score was made. So I'll add up all those scores. So I'll have the total. Now, in how many innings that much have been scored? So let's say 6 innings it was scored. I'll divide by 6. So I'll be getting the mean, or I will say the average in each inning how much is being scored. So that is what mean. This is what we have learned, and this is all we know about mean. There's nothing new, to be honest, in the mean part. Just now we have seen the group data. So how can we deal with that group data? How are we going to calculate the mean in that case? Because over there in the group data, if you understand, in the case of group data, when we say 0 to 10, 10 to 20, 20 to 30, and so on. And between 0 to 10, we are having, let's say, 7 people. Over here, we are having 5 people. Over here, we are having 9 people, and so on. In this case, I don't have the individual score. That means someone has scored, let's say, 5, someone has scored 9, someone has scored 2, someone has scored 1. I don't have the individual score. I would have the individual score. I would have added all them up and divide by the total number of students who have attempted it. But I don't have the individual score. So I have to come up with some certain formula which will help me out calculating the mean. So to calculate the mean, this time we are having not only single formula, we are having 3 formula. Or I would say we are having 3 different methods to calculate mean. Why the need of 3 methods? I'll talk about it. Let's first list it out. What are these 3 methods? Most simple thing and the obvious one, direct method. If we are having a direct method, why should we go any indirect method? But we can go for indirect method. The name of other 2 methods are assumed mean. In this case, we are going to assume a mean. And finally, we are having step deviation method. Finally, we are having the third method, which is called as the step deviation. You'll realize why 3 methods and why we are being told about the 3 methods. Let's first start with the direct method itself. Now, as I mentioned, why the whole change is there? The whole change is because we are dealing with a different kind of a data. But if you observe this data, sigma fi xi divided by n, does it make any sense? No, it doesn't make it any sense. Doesn't make any sense basically. So what I have to do over here, I have to come up with a group data so that I get a better clarity. So let's come up with a group data. This is a group data. We are having classes 0 to 6, 6 to 12, 12 to 18, 18 to 24, 24 to 30. Now we have been given frequency, how many people are there in this particular class, in this particular class, in this particular class, and so on. Now, I don't know the exact scores. I cannot do the direct addition and the division over there. So I will be taking up average of that particular class. So let's say some person has scored 2, some person has scored 4, some person is lying in between all this 0 to 6. So I will be taking what? This 0 to 6 class, I'll be taking the average of this class itself. So 0 to 6 is there. What will be lying exactly in between? So 0 to 6, 3 is lying exactly in between. 6 to 12, what will be lying exactly in between? 9 will be lying. So basically, I am taking the average of the classes itself. And I am taking the mid value of those. So I am taking the mid value, I'll be calling that as the class mark. So this is the table, if you know. This is the table which is in front of your screen. I have represented this. I will be coming up with a new thing which is called as class mark, represented by xi. And what is this? This is the mid value of our class interval. And why the need for the mid value of the class interval? The simple reason behind it is that, as I told, there will be many people lying in between 0 and 6. I don't know the exact score of those, but I don't know the exact score, but I have to consider them. So 5 people are there in between 0 and 6. I don't know the score. So if I assume the exact mid value, that is 3. So 3 is the mid value and 5 people are there. So 5 into 3, that means 15 will be the entire sum of it. I can do the addition directly, and this is exactly what we are going to do, because in the formula, in the numerator, we wanted what? Sum of the observation. So 5 people, each having 3 scores. So 5 into 3 is 15. So 15 coming from this. 4 people having the exact score, let's say 9. So 9 into 4, 32. And so on. I can go on. I can do the addition. I can come up with the total sum in the numerator. In the denominator, total number of people I can find out. How, sir? You can observe the frequency. Frequency, right? So frequency is indicating the number of people. So 5 people lie between this. 4 lies between this, 1 lies between this. In total, how much we have? In total, if I add the frequency, I'll have 20 people. So 20 over here is representation of what? The total people which are part of this data. So sigma fi, which we call as the total value, n, is the total number of people part of this particular data. So important part is understanding class mark, which is mid value. So next thing I'll be adding up over here will be class mark, which is xi. So xi, midpoint of this, that means 3. Midpoint of this, 9. Midpoint of this, 15. Midpoint of this, 18 plus 3, that means 21. Midpoint of this, basically what do you have? 24 plus 3, 27. So xi is the class mark. Xi over here is the class mark. So I'll be writing up the next column. Understand one thing, in statistics, each and every time there will be steps followed. So just remember the steps, and if you follow the step blindly even, and the first time I'm saying blindly, because statistics is a mundane thing where you have to repeat each and everything multiple times. So that is why I'm saying we have to just remember the steps, and if you're following the steps correctly, you'll be reaching to the straightforward answer. Make up the next column indicating what? Class marks. So we are having the class mark xi written over here. We have done the addition of frequencies, right? Now, the next thing what you have to do is multiply this column with this column. Frequency with xi. I told you the reason. Sorry. Xi being multiplied with xi. Fi multiplying with xi. What is this fi, xi? I is basically iteration. This is your first group, this is your second group, this is your third group, fourth group, fifth group, and that is what it is. Frequency of first, x for first. Frequency second, x second, and so on. That is why fi xi is written over there. What you are going to do? Do the multiplication. 5 into 3, 15, sir. 4 into 9, 32, sir. 15 into 1, 15, sir. Go on doing this. Go on doing this, you'll be appearing with the next column. The first column, these two columns are given. You make up the third column, which is class mark. You come up with the fourth column, which is fi xi. That means multiplication of these blue column over here. Once you have come up with this, what I told, 5 people, each scoring 3. So 5 into 3, total of there is 15. 4 people scoring 9. So 36 their total. Add all their total. Total is coming out to be 300. So total value, mean is what? I hope you remember the formula I have written previously. Sum of the observation divided by the number of observation. In this case, what is happening? I have done the sum, and sum is represented by what? Sum of observation is being represented over here by sigma fi xi. What is sigma? Sigma is a Greek symbol to represent the addition of all the values. So addition of all the values of these. 15 plus 36 plus 15, 126, 108 is coming out to be 308. So sum of all the observation is sigma fi xi. Next thing, sir. Next thing over here would be what? Next thing is basically the total number of observations. The total number of observation. Total number of observation, if I talk about, that will be sigma fi. Sigma fi. The total number of observation in this case is 20. Now, you remember the formula for mean? I told you. So mean is sum of the observation, which we have written as sigma fi xi divided by sigma fi. Let me correct this one. Sigma fi. The total frequency. You have both the values, 300 by 20. So let's do that part. 300 divided by 20. So 0 cancelling out 0 by here, 2 cancelling out 30, 15 times. The mean in this case is coming out to be 15. And that is how the direct formula works. So direct formula is having a simple formula, straight thing. It is having the straight thing. The formula was listed over here. This was the formula. Sigma fi xi divided by n. What is this n? So you have done something else. N is nothing, but n is the same thing. N is equals to sigma fi. And that is why the formula can be written as, what is x bar? X bar is a representation of mean. If I have to represent mean, I'll represent in the form of x bar. X bar is equals to sigma fi xi divided by sigma fi. And over here, it's I equals to 1 up till n. What does that mean? That it will be going for each and every group, each and every class interval for first, second, third, and so on. N means the last class interval, so it will be counted for all of those. So over here, we are having the formula, and this is how it works. Sigma fi xi divided by fi. It's basically a transformation of sum of all the observation divided by the total number of observation in a mathematical form, and convert into mathematics. Many people like don't understand what is happening. So I have given you the explanation over here, and I hope you realize how the group thing is also similar to the normal thing what we do. So here we have once again the final look to what we have done. Take a good look about it, then we move on to the next thing. Sorry. Now over here, you know the direct method. So what's the difference can happen in the question? The question will come in this form, you'll apply the direct method, you'll get the answer. That's a very common thing. So will there be any change to the problems? Yes, there can be change in the problem. Observe this data. Each and every calculation has been done for you. There is no part of it that has been left for you. The question in this can be formed in this manner, that we are having one frequency missing over here, which has been represented in the form of P. So when the frequency is missing, so when you do the sum of the frequency, it will be coming in the form of P, 72 plus P. And when you do this Fi Xi sum, it will be coming in the form of P once again. Now, how will you get to know the value of P? For such kind of a problem, since we are having one unknown, what is that one unknown? The one unknown over here is simple P. P is missing element, one of the frequency which is missing. So when we have one unknown, we should be having one equation to help us calculate that one unknown. So how will you get that one equation? In this case, the mean will be given to me. In this case, the mean will be given to me. And when the mean will be given to you, so when you apply the formula, mean is equals to sigma Fi Xi divided by sigma Fi. So basically, you know the mean, you will put up the value of mean. You'll put up the value of mean, and sigma Fi Xi you'll put up the value you have in terms of P. So in terms of P you'll put up the value, and in terms of P you'll be having the frequency. So everything would be known, only one thing will be missing, that is P. You can definitely find that out, and that is how the difference of the format can be there in such kind of a problem. Alright, and that will be repeated in the case of mean, median as well as mode. Every time that the difference would be there. So till now what we have covered about? Till now, we have talked about, first of all, the importance of statistics. Then we have talked about the types of data, the central tendency. In between, I have talked about how and why central tendency are we are learning about. And finally, to calculate those central tendency. The first one we have picked up, which is mean. For that, I had talked about the direct method just now. Now, there are two other methods. First of all, why are we learning those two other methods? We are learning those two other methods because the method which we have learned over here till now, this works well with most of the data, but sometimes the data numbers are very, very big. So over here, the sigma Fi, the sigma Xi, they are, let's say, in terms of 1000, in terms of 100, and a big values are there. So calculation becomes very complex, and no one wants complex calculation. In the previous chapter also I told you, surface area and volume. Calculation is something many people avoid, and they have in their head that, oh, I don't want to do it, and in that process itself, they lose marks. So you have to avoid it. So when we have big values over here, this method seems to be more bigger. No one wants to indulge in too much calculation. So there are methods which are less calculative. When we say less calculative, they will ease your calculation process. How? I don't know, many would disagree, but yeah, that is the case truly. Let's take a different data set. This is our new data set over here. The class interval, the number of students. So from 10 to 25, we are having 2, from 25 to 43, and so on. The data is in front of you. Now the next method is called as assumed mean method. The method is called as assumed mean method. So the name suggests assumed mean. Yes, in this case we are going to assume our mean, assume that this will be our mean, and we'll making some correction to that mean. How will we make correction? So the data, class interval is given, the frequency is given. So the next thing what we do in each and every time, the direct formula is to write down the Xi value, which is our class mark. So in this case also we are going to do the same thing. In this case also we are going to do the same thing. We are going to write out our class marks. So midpoint 10, 25, the difference is of what? 15, so 15 half is 7.5. So added 7.5 to 10, we are having 17.5. And same I have done for each and every time. Many people might have the confusion, sir, how to find the midpoint. See, the class interval, observe the class interval, 25 minus 10. How much it is? 15. 15 is your class width. This is your class width. What do you need to do? You have to basically find the mid value. So class width reduce it to half. So 15 by 2, that means 7.5. So this will be the mid value. This will be the mid value. So mid value would be from the lower limit. So 10 is the lower limit. So 10 plus 7.5. Next one, 25. 25 plus 7.5. Next one, 40. 40 plus 7.5 and so on. You are going to find out the class mark. So don't get confused about the class mark at least. This is the first and the most basic thing. Repeat it each and every time. Up till this point of time, we have done the same. The next step, what we do in the direct method is multiplication of fi with xi. Over here, since the name suggests assume mean method, so we are going to assume a mean. How are we going to assume the mean? So over here, the next thing what we'll be doing is, let's first of all talk about the assumption of the mean. How many values do we have? 1, 2, 3, 4, 5, 6. Alright, 6 values are there. Now, when we have 6 values in total, if I want the middle value, exact middle value, which will be the middle value? Now, this we have done in the case of, I believe, median, right? In the case of median, we used to find the exact middle one. When we have odd number of values, the middle value is easy to find. For example, if I write a random data over here, 2, 4, 7. So, over here, the middle value is what? So, 4 is the middle value because 1 on the left, 1 on the right, right? So 1 on the left and 1 on the right. But if I add one more number over here, let's say over here, this time I make a difference over here. 2, 4, 7, 8. In this case, now find the exact middle value. So now which will I say? 4 or 7? Which one is the middle value? Both are like exactly in between because one on this side, one on this side, these two exactly in between. These two are our middle values and we can assume anyone as the middle value. I can take either 4 or I can take 7. Both can work for me. I'll take any one of them. So in this case also, since 1, 2, 3, 4, 5, 6. In total 6 values are there, which means even number of values we have. So we will be having two values exactly in between. What are these two middle values? 1, 2, 2 above, 2 below, and these two exactly in between. These two exactly in between. Right? So now among these two, I'll be selecting the middle value, and since in this case even number of places, so these two are the middle values, I'll assume anyone. Both will work for me. Either you take this one or this one, both work for me. So let me take this one. And as I mentioned, it doesn't matter whether you take the upper one or the lower one, the answer will remain the same. Why? Because you are assuming a mean and then doing a correction to it. So you have assumed this one. So over here when you have assumed this one, so this is your assumed mean first of all. 47.5 is your assumed mean. Let me write it clearly over here. Assumed mean is equals to 47.5. And we call this as A. So now, the next column which will be coming over here is not fi into xi. We will be coming up with a new variable over here which is called as deviation. Deviation. How much deviation we have from the assumed mean? How much deviation we have from the assumed mean? Deviation is indicated by di. And it is basically the value we have, the class mark minus assumed mean. So over here, the next column is of di, and di is, how can be di calculated? Di is calculated by subtracting the assumed mean from the class marks. So if we are having for 17.5 minus 47.5, negative numbers will come. So in the upward part, the negative number, exact that value 47.5 is what we have assumed. So for that particular value, we will be having zero deviation, no deviation at all. The word deviation, English language, the same thing, no deviation at all. So zero, exactly zero. Then after this, in the bottom part, we'll be having positive because these values are greater than 47.5. So deviation, we can add up. This is the next new column coming up. I've told you deviation. I've told you how to calculate the deviation part. In the direct method, fi multiplied with xi. In this method, the new variable which is di is going to be multiplied with what? Is going to be multiplied with xi. Xi multiplied with di. So the next column appearing over here is fi into di. So each and every time the two columns will be multiplied, and in three methods that variable will be changing. In the first one it is xi, in the second one it is di. So hence fi di. Rest of the thing remains the same. What rest things are? Adding up all the frequency, sigma fi. Adding up all the values of fi di, so this is sigma fi di. Alright. So this much I hope everyone can do. The first column, two columns are given. The third you will write, come up with the di, multiply with fi di. So sorry, xi di, you'll be coming up with the sum of it as well. Why we are emphasizing on this method? Because we told that less calculation would be there. The less calculation will be in this form. If you observe, the sum of this FIDI will be small. Why small? In between 0, above negative value, and below we are having positive value. The sum will be somewhere in between. It will not be a very big value. And that is what we are going to involve in our calculation. How we are going to involve in our calculation? The method which we know of, assumed mean is this. The formula directly works. For the previous case, I explained the formula. In this case, the formula says x bar, which is our mean, is equals to assumed mean. We have assumed a mean. Now we are going to do the correction of it. So correction in what form? Plus 1 upon n. N I told you is what? Sigma fi. So n is in the denominator. So basically sigma fi di divided by sigma fi. This is what we are going to do. So this correction factors is very much similar. In the previous case, mean was sigma fi xi divided by sigma fi. Over here, sigma fi di divided by sigma fi is simple addition to the assumed mean. So over here, assumed mean is what? Assumed mean we have 47.5 plus sigma fi di is 435 divided by the total frequency. The total frequency is 30. Divided by 30 over there. 30. That's it. So doing the calculation over here, if you want to do it, cancelling out by 3, this will be 10. And this will be, so 1 times 3, so 13. 13 means 4 times 12, 15. So 145 divided by 10, 14.5. So 0.5, this is 48. 48 plus 4 is 52. 52 plus 10 is 62. I hope the calculation is correct. In case the calculation is incorrect, please make sure that you help me out over here to rectify this error. So this is how we are going to do. 47.5 plus 5.5, this is 48. 48 plus 4, 48 plus 4 is 52. 52 plus 10 is 62. And we have our mean by the new method, which is assumed mean. To be honest, the calculation is very small over here. The large numbers which have been there would have been eliminated in these two columns. And that is why this method plays an important role. And this is what you follow when the numbers are very big. Otherwise, you can go for direct method as well, right? So yeah, this is assumed mean method, and we have done only the second method now. We have to move into the third method, which is called as the step deviation method. I hope you have understood it. The difference over here, rather than fi xi, we are having the third column, which is di. And same thing is going to appear in the step deviation. Over there, till this point of time, everything remains the same. Over there also, you are going to assume a mean like this, 47.5, a one value which is lying exactly in between. And you are going to come up with deviation. But over there, a new variable have appear, and with that, you have to multiply xi. So if I have to show you directly, so let's move on. So over here, we are having a data. This is the data. This is the class interval. This is the frequency. This is the mid value. So now next column should be what? The assumed mean. 1, 2, 3, 4, 5. In this case, we are having 5. So now 2 upwards, 2 downwards. 2 gone upward, 2 gone downward. This is our exact value. So this is our assumed mean. Assumed mean in this case comes out to be 50. And good thing is now we can find out the next column, which is di, and di is what? Xi minus a. This is our next column. So you can find out the values in the next column. So next column, when you fill it up, subtracting 10 minus 50, 30 minus 50, 50 minus 50, 7 minus 50, 90 minus 50. I believe everyone can do the calculation. And this is how the values will be coming up. So yeah, this is the values coming up. Now, in the previous case, multiply xi with di. No. Don't go that simple. We have to make up a new thing, which will be ui. This is basically called as unit interval. Don't get into the name of it. The new variable is ui, which is what? Di divided by h. Or you can say di is what? Di is xi minus assumed mean. So divide by h. What is this h, sir? If you remember, when I was talking about the class interval, I told you lower limit, upper limit. So upper limit minus lower limit, we are going to have the class width, and h is that class width. Yeah, this is it. So now we can think about the ui. we will be adding up a new column ui, which will be just dividing the di with the h value. H value in this case 20 minus 0 is 20. So 20 is the class width. So h over here is 20. So for that you can do the division of these value, minus 40 by 20, minus 20 by 20, 0 by 20 and so on. So we'll be coming up the next column, which is ui like this. Take a good look about it. Sorry, pardon me. Still, I'm not feeling well. Still, I'm having the throat thing. So, you don't waste time on that part. You focus on this part. This is it. Once we have the next column, which is ui, which is the new variable. Now we are fine doing the multiplication of xi with ui. So, xi ui is what is the next thing up. You'll multiply, come up with the values. When you come up with the values, here we have the values coming up. This column multiplied with this column, not xi being multiplied, sorry, fi multiplied with ui. So not previous thing, I should correct myself, not xi, you should multiplying fi with ui. Fi with ui over here. Fi with ui, you will be coming up with the next column, which is this one. Once you have all these value, now again the formula will appear, and to be very honest, the formula is exactly the same. There is a minor difference over there. Assume mean plus sigma fi di was there. In this case, it will be fi ui divided by sigma fi. But since u is having something in division, that is h, so that has to be balanced. So I'll be multiplying that part with h. This is the formula. So this is nothing. If I have to write it, x bar is equals to a plus. Now sigma fi ui is what we have done, and in ui you are having h in division. So I'll be balancing that h by multiplying this entire thing by h. This is the formula. You have the value of a, which is 50. You have the value of h, which is 20. You have the value of sigma fi ui as 15. You have the value of sigma fi, which is 100. Put down all the values. The correction factor is there. You'll get the mean. And yes, this is it. This is it about the third method, which is step deviation, and these are the three methods. In the first one, the first column was involved, xi. In the second one, di was involved. In the third one, ui is involved. So yeah, addition of each and every column, but they say that the calculation have been reduced. You will understand when you have big values. In the examination, the examiner, if asking specifically that calculate the mean using the step deviation, you have to do all this and give the answer. If it is not mentioning, it is up to you, whichever suits you better. Where you find your comfort that, okay, I'll go with this method, you can go about that method. And that is how you can calculate mean by any of the three methods. And we are done with the first part of the central tendency, I would say the most lengthiest part of all. Next two will be very simple. What are the next two? The second one is median. So here we enter into the next part, into the median. So for your comfort, here we have summed it up. So you can note it down if you haven't done till now. And as I most of the time say, if you haven't done till now, you will not be doing now also. By direct method, assume mean method, and the step deviation. Next thing appearing over here is our median. So median, what is median? Median is the exact middle value, So I make, let's say 5 people sit. Who is sitting at exactly in between? If I make 10 people sit, who is sitting exactly in between? So for all these cases, till now we have dealt with the raw data. So when we have raw data, things were simple. What simple, sir? So we were having, let's say if people are, if we are having odd places, number of places, so things was very simple that you cannot divide n directly, so you'll add 1 and divide by 2. So for example, 5 people are sitting, so 5 plus 1 is 6, 6 by 2. That means the third person is lying exactly in between. So this was for odd. And when we have even, in that case, 2 people will be in between. So n by 2 and n by 2 plus 1. These two will be exactly in between. So 10 people are there. So 10 by 2, that means the fifth person, and n by 2, that means 5 plus 1, 6 person. Fifth and sixth person are lying exactly in between. So which one I should take? I'll take the average. That will be our median. But the things differ over here when we have the group data. And yes, in this particular grade, we are going to deal with the group data. So here we have the group data involved. For the group data, we are having a straightforward formula. But sir, formula you have shown, but I don't know how to apply the formula. For that, I will show you the data and make you understand how to apply the formula. So first of all, please make sure that you have noted down the formula. Then when I make you understand what is L, what is N, what is F, what is H, what is CF, you will get a better clarity. Here we have the data. Now, in this data, we are going to come up with a new thing. What is this new thing, sir? We are having a frequency. All right. So there were 5 people lying between 5 to 10. Okay, good enough. There were 6 people lying between 10 to 15. Very good. Now, if I ask you how many people lie below 15, how many people lie below 15? So you would say 5 is also there. This is below 15. 6 is also there below 15. So both of them are part of it. 5 plus 6, 11 lie below 15. And that is what exactly cumulative frequency is. Cumulative frequency is the addition of each and every successive frequencies. So for the first one, it will remain as it is. For the next one, 5 plus 6. Add to the next one, 11. Next one, add 15 to the previous one. 11 plus 5, that means 16 plus 5, 26. Plus 10, 36. Plus 5, 41. Plus 4, 45. Plus 2, 47. Plus 2, 49. So it was a very quick succession. I could not understand anything. To understand, I told up till 10, 5 people. Below 15, both of them, so add both of them. Below 20, all 3 of them, so add all 3 of them. Below 25, all of them, add all of them. So 15 plus 5 is 20, 20 plus 10 is 30, and 30 plus 6 is 36. So that's why the cumulative frequency, the total frequency up till this group is 36. So this number represents the total frequency up till 45, and hence this 49 is the sigma Fi, which we also call as number. So total number of people who are part of this data are 49. N is clear. N is the total frequency. So N by 2 can be easily calculated, right? 49 by 2, right? So in the formula we have N by 2. So N is what? Total frequency. N is the total frequency. Then, sir, we are having L. L is the lower limit of modal class. Modal class, what is this class, sir? We are having class interval. We are having different class interval 5 to 10, 10 to 15, but we don't know which is the modal class. For that, this number will help. N by 2. So N by 2, the total number of frequency divided by 2, we are having 49 by 2. This is 26 point, not 26, sorry, 24.5. 24.5. Now, look into the cumulative frequency column. Look into the, sir, where is the column? Over here, I have added a row. You'll be adding a column like this. So don't confuse yourself with that part. So you have added a cumulative frequency column. So in that, find, where you'll find 24.5. Obviously, in 11, you cannot find. 11 is very small. So next thing is 26. So 24.5 is less than 26. So obviously, which one would be containing 24.5? So this thing will be containing 24.5, and over here, this group 15 to 20 is our modal class. For modal class, find the value of N by 2. Once you have the value of N by 2, and then see in which part of the classes it will be lying in terms of cumulative frequency. 24.5 will lie in this one because 26. So after 11, 12, 13, 14, 15, 16 and so on, 24, 25, 26. It will be part of this one. It will be part of this one. So up till this 5 plus 6 is 11. So next number will be included in this. That is why 15 to 20, and hence we have found out our modal class. So modal class is there. So you can find the lower limit of the modal class. So in this case, the modal class is what? 15 to 20. 15 is the lower limit, 20 is the upper limit. So 50 is our value of L. L is known, N is known, so N by 2 can be known. Then we have frequency. Let's write down frequency itself. Frequency of what? Frequency of modal class. Modal class, we have already been solved. What is modal class? So over here, this is our modal class. So in this class, what is the frequency? Frequency is this one. So frequency is 15. So for this class, we are having frequency 15. So that means our value for F is 15 over here. Alright. L done, N done, F done. What is CF? CF is cumulative frequency. We have just now calculated, but which one? Which one are we going to consider? Over here, all of them are representing cumulative frequency. Which one? So in this case, if this is your class interval, so before this class interval, whatever is the cumulative frequency, that is what you are going to consider. Repeating once again, frequency will be considered of the modal class. Frequency will be considered of modal class. Cumulative frequency will be considered of the class preceding the modal class. So this is the class preceding the modal class, and over here the cumulative frequency is 11. So 11 will be considered. So what I am going to write for CF? CF is cumulative frequency of class preceding the modal class. Very long explanation, sir, but the answer is going to be very simple. The answer is going to be very simple. So each and everything done. H I have already explained. H is the class width. In this case, if we are having how much? We are having 15 to 20, 20 to 25. Each and every case we are having 5. So class width is upper limit minus lower limit, 5. So H value is 5. Repeating all the variable involved over here, the first thing was lower limit of what? Modal class. Find the modal class. How? Find the total cumulative frequency, or find the total frequency. Sorry, not total cumulative frequency. Find the total frequency, which will be the last value of cumulative frequency. That is our value of n. So n by 2 can be found out, and find in which part of cumulative frequency it will lie. So in this globe it will lie. That's it. So this is it. So now, if this is the modal class, so for this the lower limit, the class width, H value can be find out, the frequency of it, and then the cumulative frequency of the preceding one. That means the 11 over here. Once you have all these values, put down all the values over here, and we'll find out the median. And that is how a single formula will be helping you median. And over here, there is no complication that the data values are less or more. You have only one formula. You can go about by this formula, and that is how you are going to calculate the median. But for that, you should know all these things. If you know all these things, you can come up with the answer over here very simply. So if you haven't noted down, please note it down now, and we are going to move into the next part of it, which is mode, which is the simplest among all of these. Formula for the group frequency distribution. What exactly is mode? What exactly is mode? If I ask your favorite chocolate, so when we say favorite chocolate, so majority of the student will raise their hand or will say that this is my chocolate. So it might be Dairy Milk, it might be Kit Kat, it might be Galaxy, it can be Mars, it can be Bounty, it can be 5-star, it can be Lindt, it can be any other chocolate in the world, I don't know. So in this case, let's say Dairy Milk appears to be the common one. Common one means majority of the people will agree on that. Majority of the people. So maximum number of support for which chocolate we are having, that will be our mode. So different politicians are there in the democracy. So majority of the vote goes to this particular politician. That is the mode of the data. See, the real life application of statistic. Mode is basically the highest number of votes given to any particular politician among all of them. So over here, if you have written the numbers 2, 3, 3, 2, 3, 1, 4, 7. In this, the most repetitive number is what? 3 is the most repeated number. The mode is simply 3. This is the mode. Now, in the form of group data, things will be different. In the form of group data, things will be different. Over there, we'll be having numbers from 0 to 10, 10 to 20, 20 to 30, and so on. This is our class interval. This is our frequency. We'll be having some frequency ahead of it. For this, again, mode is very simple to calculate. A simple formula and apply it. For the formula, this is the formula in front of you, and this time I have written them all so that you have to don't engage more time while writing. Just take a screenshot or just quickly write in one go. And this is all we have. In this case, L again is the lower limit of the modal class. So previously we were having the median class. Now we are having the modal class. Modal class can be easily found out. Read the last statement. Modal class is the class with highest frequency. The class with highest frequency. So highest frequency, how do we get to know? So for that, you'll have to see the data. I hope you have noted it down. In case you haven't noted down, please pause the video. You'll get to understand what are these variables and what do they mean. So when you note them all down, so now this is the data in front of you. Number of patient, age of the patient, sorry. So between 0 to 20 age group, we are having 35 patients. Surprisingly, the majority of the patient come from 20 to 40. I don't know why. What kind of a data it is. Sometimes the data is first, sometimes the data might be wrong because the collection method is wrong. So we don't need to engage on that part. Our part over here is to process the data. So let's process the data. So which of the age group is having the highest frequency? And frequency is this. This is our frequency, number of patient. So if you observe carefully, majority of the people lies in this. The highest frequency will indicate the modal class. And in this, the modal class, you'll have the value of L. This is your L, the lower limit. Lower limit is the value of L, which we are indicating for the modal class. L value come. Then we have multiple things involved, like what? F1, F0, F2. Now, one appear in between, the first one. So F1 is the frequency of the modal class. 315 over here is our F1 value. The frequency of the modal class is F1. Frequency of the modal class is F1. F0, 0 comes before 1. So frequency of the previous class. Previous class is this one. The frequency is 35. So F0 is 35. F2, frequency after the modal class. So this is the modal class. So after this class, frequency is 120. F2 is 120. That is how things need to be done. So the formula is very simple. L plus F1 minus F0. So H is the class width as usual. F1 frequency of the modal class. F0 of the preceding class, the frequency of the preceding class. And F2 frequency of the class succeeding. Highest frequency indicates the modal class. First thing to find the modal class. Second thing to find the lower limit. Then F1, F0, F2. That means for that case frequency, for the previous case frequency, and for the next case frequency. H, subtract the upper limit from the lower limit. You'll get the class width. And you have all the values. You'll find out the mode very easily. A simple formula. Among all of the central tendency, mode is the simplest to find out. And that is how for the group data you are going to find out. Apply this formula. And for the group data, the formula works. Other than that, they'll not be asking because ungrouped we have already learned in grade 9th. So for the data, I've shown you how to work. The formula I've shown. And that is all we have in the case of mode. Mean done by the 3 methods. Median done by a single formula. Similarly, mode done by a single formula. Is that also? Since we have talked about the central tendencies, now there would be something which will be relating all three. Yes, we have something which we call as the empirical formula. Why empirical? The name empirical comes because we have come to an understanding after doing some calculation. What calculation we have come from? We have come from after doing the calculation, which is very simple, that okay, there is a relation between the mode, median and the mean. All three have been given. So there is a relation which will be of this form. And one important thing, that all the three things would be of the same data. So don't make a confusion. For one data you have taken of the mode, for another data you have taken of the median, and for another data you have taken the mean. No, for the same data if you have considered all, so for them this will be the relation. So let's say if you know the median and the mean, you can always calculate the mode of that data. If you know these two, you can always calculate the third one. So how does it work? It simply works if you observe in this problem, not this one, in this question over here. What was in the previous slide, sir? Why you just simply skipped out of it? Basically, in the previous formula, if in the previous formula, you can write it in multiple form. You can write it as 3 median equals to mode plus 2 mean. You can also take it as transferring this mode on this side and the mean on the other side. Multiple way of writing it. I don't want to make you understand there are multiple formulas. It's a single formula. Just transfer from one side to another side and you'll have the understanding. So that you can done. Rather than going into the formula, just putting down the value and then doing it. So this problem will help you out with that. If we know that we have the median of 8, okay, so let's first of all write down the formula itself. Mode is equals to 3 times of median minus 2 times of mean. So if I know that the median is 8, so I'll put down the value 3 multiplied with 8. All right. A mode of 4, so 4 is the mode. The mean is what? Something missing. So minus 2 times of mean. Okay. So if I transfer this 2 times of mean on this side and transfer this on the other side, so 2 times of mean will become positives. And this 4 will go in the negative form. 3 into 8 is 24. Minus 4, that means 20. And we have 2, so transfer 2 on the other side will go in the division. So mean will be what? 20 divided by 2, that is 10. Mean is simply 10. Mean is simply 10. And you have seen, if you know any of the two, you can find out the third one. And this is what the exact thing what we do by empirical formula. By empirical formula, for the group data, you apply the formula and you get the things. So, sir, is that all? We are tired already. Even I am tired. Yeah, that is all we have in this entire chapter. If I have to summarize, you have already seen the summary. Why should I summarize anymore? Please make sure that you know central tendency. Please know how to calculate mean by all three methods. You should know mean, median, and the empirical formula. That is all. Done and dusted. Have a great time. Enjoy yourself. Take care. Bye, everyone.